So good morning. Today, I'm going to talk about building and deploying highly scalable Node.js microservices and how to verify the performance of those microservices and do diagnostics for performance when they're deployed. I'm Chris Bailey. I'm the chief architect for Node.js and Swift at IBM, and I'm joined by my colleague Chris Vignola. Chris works on cloud-native Node.js, so that's making Node.js ready to work in cloud deployments. So before we get started, we're going to talk about some key technologies for cloud-native. So the Cloud-Native Computing Foundation, which is part of the Linux Foundation, which is where the Node Foundation sits as well, they talk about a number of key technologies. One of those is Docker. So who here is using Docker today? Okay, that's actually the vast majority of you. Okay, so how about Kubernetes as a way of deploying, clustering Docker? Okay, that's a lot less, possibly about 20%. Okay, so how about Helm? Anyone using Helm? Okay, a small handful. How about Prometheus as a monitoring system for metrics? Okay, a few more than Helm, but not many. And finally, what about open tracing in Zipkin? Anybody here? Two people. Okay, so there may be two people in the audience who don't learn anything in this session. Sorry. But for everybody else, hopefully there's going to be a lot of new stuff, and hopefully it's going to be interesting and informative. So those are the key technologies we're going to be talking about. But first of all, let's talk about microservices performance. So what's the key characteristics for a microservice when it comes to performance? Well, one of them is actually about I/O performance. So when you're deploying microservices, the idea is microservices are small, single task focused capabilities. And you build up an application using several microservices. So that means there's going to be a lot of connections for any user responsiveness. Anything that happens in the browser is going to involve talking to an API that has several microservices behind it. So actually, I/O performance becomes really key for the overall performance of your application and for being able to do large scale. So this is how Express.js does on a benchmark that takes a request, does a database fetch, does an update to the database, and does a response. So kind of a CRUD operation in Node.js. And here's the equivalent from Spring Boot, which is a microservices framework in Java. So for this I/O-based benchmark, Express is actually faster than Spring Boot Java. Now, actually, if you move to really highly computational tasks, things that use a lot of CPU, Java tends to be faster. But you don't do highly CPU-based workloads in Node.js because that blocks the event loop, and we all know we shouldn't block the event loop. So for I/O-based workloads, Node.js is actually faster than Java. Okay, a second key characteristic is startup speed. So when you're deploying microservices, if you want availability, if there's something wrong with the application, you shut it down and you restart it. So that time to restart actually affects how fast you can react to an outage and get availability. It also applies to scaling. If you have additional load, you want to add new instances of your application, right? You want to have not just one Node Express application, you want to have 5, and if there's a lot more load, you want to grow to 6, 7, and 8. Now, your ability to react to incoming load depends on how fast you can add new instances. So your ability to scale is kind of dictated to how fast you start up. So looking at the same things again, this is the startup time for Express, so around 0.9 seconds to start a Node Express application. The same as Spring Boot, takes almost 14 seconds. So on startup speed, Node.js significantly better than microservices frameworks in Java. And finally, memory. When you deploy applications to a cloud, most cloud providers charge you according to the amount of memory that you're using when you deploy your application. So the more memory you use, the more you pay. And secondly, if you're running this yourself on your own machines, the amount of memory an application uses dictates the amount of density you can have, how many applications you can deploy onto a machine. So if we compare memory, we can see that Node.js uses something like 23 megabytes. We look at the same thing in Spring Boot, 422 meg. So you use a lot less memory using Node versus Java as well. So all in all, Node's actually fundamentally a good language to be deploying microservices. Not only that, but if you look at the work that's been done by the performance benchmarking workgroup. So they are looking at a set of around 10 or so benchmarks, and some of those, unsurprisingly, align very well to I/O performance, startup, and memory. And this is how they've been doing from release to release. So in Node version 4, we had a performance on a throughput on a benchmark called Acme Air of 1,866. In Node 8, we're up to 2,914. So release by release, there's been improvements in I/O performance in Node.js. And you saw some of that information in the session about V8 this morning. The work that's been done in the V8 JavaScript engine under Node.js is enabling this. Startup, there was a big drop when we started to focus on startup performance, and it's been roughly the same release to release since then. And memory footprint, that's almost static across releases. And to achieve this improvement in performance at 0 additional memory cost is actually really quite impressive engineering. So Node is good for microservices, and the performance benchmarking workgroup is focused on keeping those characteristics good. So how do we build scalable microservices? So first of all, you build, let's say, an Express app. And when you've built an Express app, you probably have these files, right? You have the public directory for serving static files. You probably have some tests. You have a server.js file with your Express application in it, a package.json, a README, maybe a git ignore file. And your server file will look something like this if you're doing just a Hello World app. Now, to make it ready for microservices, the first thing you need to do is add a Docker file. And a Docker file is going to contain something like this. So this says, I need to have a base image that has Node.js in it. I need to open a port. I need to install my dependencies. I need to copy that into a directory, and then I need to start it and expose the port. You might have a Docker file for tools, so that's to be able to run the same application in a debug mode or to run tests rather than a production mode, and probably a Docker ignore file. And that says, when I'm building my Docker image, don't copy this stuff over. And one of the reasons you'll do that is your local development environment might be Windows or Mac. Your deployment environment might be Linux, so you don't want to copy over your Node modules in case there's native modules in there. OK, once you've done that, Docker build, Docker run. And yes, I have Node running in Docker, and I have a microservice. Now, the problem with this is I don't want one, I want several. And I'm going to need to do that if I have to be able to scale out and deal with large levels of load. So how do I go from one to many? And that's where Helm charts come in. So Helm charts are a bunch of additional configuration files that you need to add to your project. The first is just a basic chart. This is kind of like a name and a package. So Helm charts, they're kind of like your package management system and deploy system for Kubernetes. So I have a Helm chart. Inside that, I have a very complicated deployment.yaml file that talks about how many replicas I want, so that's how many instances, what ports I'm exposing, whether it has any dependencies. I have an HPA file. This is horizontal pod autoscaling, which means how do I add and remove instances? So what this will do is this says I'm going to start off with 5 instances. If the CPU usage for all 5 instances goes over 70%, I'm going to add an additional instance. And I'm happy to grow up to 10 instances. So this is the configuration file you need to add in order to be able to dynamically scale in Kubernetes. Then I can have a service YAML. This means I'm exposing a service for other people to use. If I wanted to use some services, I would put that in there as well. And there's also a values.yaml. So there's a way of doing templating and sharing configuration across all of these files. So I build a bunch of Helm charts. Once I've done that, I do a Helm package and a Helm install. I get my 5 instances because I started off with 5. And through auto-scaling, I can grow up to 10 if I need to. So between Docker and Helm charts, I can now deploy a scaled microservice. OK, but once it's there, how do I know that the performance I had for my single Express application on my laptop matches when I've deployed it to this cloud cluster, and there's 10 of them running, and it's in an application that has dependent services? So the challenge for microservices performance is this is what a microservice might look like. You start off with a browser or a mobile device, and that's how users interact with your overall application. So a browser will make a request, it will go through some kind of load balancer, and it will come to your web delivery tier. Now that's going to be Node.js Express or Loopback or Happy or Kraken. From there, in order to handle that web request, it might need to make use of some back-end services. So let's say we've got a user who's going to order something from an online catalog. So that web request needs to use the order service. And that may make a request of a Mongo database to, I don't know, look at previous orders, get an order template, something like that. The next thing we're going to do is we're going to check to see whether we've got sufficient inventory to be able to actually satisfy the order. So we go to the inventory service, and then that goes to a MySQL database to find out how much inventory we've got. And then that's going to return back to the order. If it's OK, the order might write to the Mongo database, and then we have an end transaction. So what this looks like in terms of the timeline is from the browser sees it takes this long for the whole thing to complete. Now, inside that, the load balancer sees the transaction taking a similar amount of time. The difference is a bit of network latency. Under that, you have your web app. Behind that, you have an order service. You have the MongoDB call. You have the inventory service call, which then calls MySQL. And you have the second MongoDB call. So I need to be able to understand where in this series of transactions all of the actual time took to understand where my performance bottleneck might be. So this is our challenge. It's when I have this interconnected mesh of services, where in amongst this mesh is my performance problem? So this is where open tracing and Zipkin comes in, that thing that two of you have heard of, and that is hopefully new to everybody else. What Zipkin does is it does request tracking. It follows a transaction. Actually, you can do it from the browser, right the way through all of your transactions, right the way back to the browser. And it does this by adding some HTTP headers into your request. And when that goes to your web app, you need to take those HTTP headers and propagate them into anything you make a downstream call for. So it's all about propagating these headers, and every part of the system then making a data record, which it then sends to a Zipkin server, and this gives you a visualization of what your performance looks like, which hopefully is going to look like this. So that's quite complicated. I have to get some headers, I have to read them, I need to put them into my outbound requests, and I need to send the data to a Zipkin server. Now, luckily, my team creates something called AppMetrics, which is a monitoring system for Node. It's open source. And we have just created an extension to AppMetrics called AppMetrics Zipkin. And this does it all for you. With just one line of code, we enable Zipkin support in a Node application to do that header propagation and to send the data to the Zipkin server. So with that one line of code, this is what Zipkin open tracing gives you. So this gives you a view of where your elapsed time is and which of the services is actually taking those time. So from this, I should hopefully be able to identify which service I believe is causing my performance problem. So that gets me to the point that I have one service. But I still need to understand what that service is doing. Enter Prometheus. So Prometheus is a monitoring system that works on a /metrics endpoint. So your application hosts an extra URL that contains a whole load of metrics data about what your application does. Now, the way you do that, again, is we have an AppMetrics package called AppMetrics Prometheus. And this will register that additional endpoint and collect a whole load of data for you. It collects data about the machine's CPU usage and your processor's CPU usage. It contains information about memory usage, event loop latency, how long each HTTP call took on each URL, how many status code 400s occurred. Right? It generates all of this data, and it exposes that /metrics endpoint that looks like this. Now, that in itself is not particularly usable. It's human readable, but it's not usable. But what Prometheus does is it provides a data store and a visualization And that visualization uses things like Graphite and Grafana, which is a dashboarding technology to build your own dashboards. And it allows you to build things like this. So I can build a latency graph for each of my individual services that collects data from all 10 or 15 instances of that service and publishes that data back to the server and allows me to build custom charts, including doing things like alerts. So if I have a system that goes down or something that starts throwing 404s, then I can have an alert to say that this is happening. So that allows me to say, okay, maybe I've realized that for whatever reason, it's running at 100% CPU. I've scaled out to 15 instances. It's still running at 100% CPU. And I need to understand why my Node application is using CPU and whether there's anything I can do to optimize it. So the next step on that is another capability, which is flame charts. Who here's used flame charts for Node performance analysis? Okay, so about a third of you. So again, we've got another tool, AppMetrics Dash. This is an inbuilt dashboard that you can host inside your application, and it shows you a whole bunch of data about the single instance of your application that you connect to. Again, adding it is very simple. It's one line of code. Require AppMetrics Dash and attach it. And that exposes a web dashboard directly inside your application. And that looks like this. So this tells you about every HTTP incoming request, every outbound HTTP request. It tells you about event loop latency, CPU and memory usage, and so on. It also, as you saw in Michael Dawson's presentation this morning at the keynote, lets you generate a node report or a heap snapshot. And there's a hamburger menu that lets you turn on profiling. And when you do that, you get this. You get in that dashboard a whole bunch of flame charts. And that allows you to understand where the CPU time is being spent at any point in time. So the higher the peak, the deeper the stack trace. The wider it is, the more time is being spent inside that function. And you can select any part of the flame chart, and it will give you a stack trace that's showing you what's using all of that CPU. Now, one of the problems is, in just about 20 minutes, I've talked about 5 technologies, all of which are new to the majority of people here, and there was a huge amount of configuration that you had to do. Now, wouldn't it be nice if there was a way that all of this was done for you and you wouldn't have to think about it? And there is. This is what Michael Dawson announced. It's our open source generator for Node applications called Yeoman Server. And Chris is now going to talk about that and show you a demo.
All right. Thank you, Chris. So, I'm going to take you on a little test drive of Yo Node Server and all the cool things that we can do with it. Can you all hear me out there? Out in the farthest reaches? All right. We're going to do a little experiment. I'm going to set this down and ask if you can still hear me. All right. Okay, so Yo Node Server. I'm going to roll up my sleeves. All right, and let's dig in. All right, let's put this away. And let's start out here. All right, first of all, it's a Yeoman generator, npm install -g. Generator Node Server brings it down. Don't forget to install Yeoman. We've got a fair amount of useful documentation out here that explains the goods, but we're not going to read through that. I'm going to show you instead. All right, so with Node Server installed, we simply fire it up. It's going to ask you a couple of questions, nothing too taxing. Project name. Optional Open API document, aka Swagger. What this is good for is if you are doing top-down style development and you've defined some of your APIs in a Swagger doc, you can put that in as input. I've got one here for my pet store. Any pet owners in the audience? Dog owners? Cat owners? Goldfish. All right. Okay. So now we also, this is an open source tool, and it generates a scaffolded project with all that configuration that Chris was talking about. Good for any Kubernetes platform. We even throw in configuration for Cloud Foundry. But we also throw in a little bit to help those who might be using the IBM cloud. There's some service enablement. It's completely optional. If you use it, you can pick various services, and it will scaffold a little bit of code to make it easy to use those as well. But we're not going to do that today. We're going to just generate out a basic project. And what that looks like over here, we see various things. Chris talked about Docker files and Helm charts. So here we see a Docker file that you saw previously. Over here is a Helm chart and the pieces that make it up. So there's our deployment YAML and our HPA YAML and all the rest. Okay, all pre-configured for you. Okay, since I passed in a Swagger doc, we get just a little bit of scaffolding of the routes for my pet store. Okay, that's just to get us started. All right, and then from there, what we can do is we can go out here and we can, playing around a little bit. Okay, so we've got some scripts in our, let's take a look at those scripts. What's in our list of things? In our package JSON, we've got some NPM scripts in here. And there's a bunch of them right there. So, you know, some of your usual things, install, start, and so forth. But we also include a tool called IDT. That's the IBM Cloud Developer Tool. It's also a free tool. And it will bring down to your development machine some handy tools that, that you might need for doing things with Docker and Helm and Kubernetes. Okay, and so if you run the install for that, it just quickly checks if you've got these tools installed yet. I happen to have them all installed. I wasn't going to make you sit through that. Okay, so it's just checking that I got them all in there. So it lets me know that, yep, that I'm all up to date, and I've got the tools that I don't have to have. They're optional, but they're really handy. So we make it easy for you to pull them down. Now, once we've got the tools pulled down, we can do things like over here. We can do an NPM run, IDT run. Too many runs, but that's how it goes. So IDT lets you do a number of things. It's about doing your work in containers. Okay, so if you're going to deploy in a container, it's good to kind of take it for a test drive, you know, before you jump into your DevOps pipeline and start sticking stuff in your, you know, your staging, your integration, your QA, and your production systems. All right, so let's run this a little bit locally. Of course, I can do npm install and npm start. That's a given. But if I want to do the Docker stuff, that's what IDT helps me to do. Okay, and so here it's going to spin up a container, and it's going to run my app. There we go. We're running. Okay, we are running, and if we check Docker, what does Docker say? Docker says, "Yep, here we're running." Okay, so it did the build and it did the run for me. It knew all the right parameters to do. These apps come scaffolded with a few endpoints that are handy. Okay, like since we passed in a Swagger doc, we rolled in the Explorer for you so you can get to your goodies there. Okay, so this is your Swagger browser. Okay, and as well as your spec. So that was our YAML that we passed in for our pet store. And also the apps metrics dash that Chris showed you before. Let's see, I've got no data here, but we can fix that. So let's give it something to chew on there. There we go, we've got some live action. Chris talked about enabling profiling. It's really easy to do. We just enabled it up there in the hamburger menu. And if we flip over here to our profiling view, well, that's interesting. It's, there we go. All right, so here's our flame graph. I think it's showing what the Explorer was doing. Okay, and let's give it a few things to think about. All right. And so, like Chris said, you can look at your call stacks and you can see where you're spending your time and this sort of thing. All right, and that's all good. Okay, and so let's jump out of there. Let's see, where'd my Docker container? Oh, yep, yeah, he stopped too. Okay, good. All right, so now we've tested this out a little bit in our Docker container, and it's time to use Helm and go to Kubernetes. So I can go back to my IDE. I just started using VS Code a while ago. I rather like it. Is anybody using VS Code? Yeah, it's not bad, right? So let's go to a run task. So that IDT tool, that one that we did the quick install of, right? It lets me do a number of things. We saw install, but I had nothing to install because it was all ready. We did an IDT run. That's how we got the app up in a container, and we were poking around looking at it. And deploy is another one we can do. So deploy, we'll deploy it out using the Helm chart to my Kubernetes environment. My Kubernetes environment is set up to be Minikube because I wasn't brave enough to do a demo out to any cloud. Always here at the conferences, the Wi-Fi is sketchy, So what we see in the terminal window down here is what Helm has to say about what it did. Took my Helm chart and it ran it, and it set us up on Kubernetes, something that it calls a deployment, and the Helm calls a release. So we were to go out here then and bring up our type. There we go. Bring up my Kubernetes dashboard, and sure enough, there's my my node server deployment, my pod, my service definition. It's all there. If I go to the pod and drill down, there's my container. If I look at my logs, sure, it's the same stuff we saw before when we were running it. Directly on my machine, not in my Minikube VM. All right, so that's all there. Now, if I wanted to hit a few of those services, I can do so easily. If I could just type a little better. Come on. The angle's weird up here. Let's see, let's bring up the Explorer, for instance. And sure enough, now you notice just an oddity here. The URL, the IP address specifically, is to my Minikube VM. It's not to my my Mac here. All right, and the port is a funny port number. You see that? It's called a node port. It's just it's a Kubernetes thing. You can use load balancing with Kubernetes, or another way to access your app is through something called node port, and it's a 30,000 port number range and above. Minikube does node port. It doesn't really have a load balancer on it, so that's why it's there, not at 3,000. Even though you notice in here, inside the Kubernetes network, yeah, there it is. See, it is at 3,000 on the internal network on my VM. But my external network looks like this, okay? And if we dug through Kubernetes, we'd find that stuff, but that command I was using for the Minikube environment makes it easy to find these things, including like my app metrics, dash. Sure, there it is, okay? And so there we are out in Kubernetes. So we went quite quickly from zero to few short questions to project, to running locally with Docker, to deploying out to Kubernetes, and all the monitoring tools that Chris talked about pre-wired into this whole experience. It's open tooling. It's free to use. And the generated projects are a good start. It's the culmination of a couple of years of our experience using these tools, so we've kind of applied some best practices as convention. But that's just to bring the bar down a little lower so that the entry is easier for you. You can change it around how you like, but we think it's a good start, and you can start by going to NPM and pulling down our generator and trying it out yourself. If you have more questions about this, you want to hear more, see more, stop at our booth and talk to us. We'd love to chat with you. Thank you very much.